Hi, and welcome to Meetings in Math. I am so glad that you are here today to learn with us. Today we're going to be looking at algebraic expressions and how can you simplify an algebraic expression. Today you are going to need your Jaguar dots. At the top it'll say 3.1 and 3.2. How can you simplify an algebraic expression? Something to write with, either a pen or a pencil. A calculator might be handy, and bring your perseverance and your determination to get through this lesson. So let's begin. So we are going to save this why is it true for class. And we're going to jump right down to where it says combining like terms. Like terms are when they have the exact same variable term. When we say constant term just means that it's a number by itself with no variable. The coefficient is the number that is in front of the variable. So for example, if I wrote 5a, it would be the 5. Okay, so now let's look at applying these. In the first one, let's look at for everything that is followed by an x. So let's look at this 7x, and we're going to read through the next, and everything that has an x in it, but nothing else, so no other variable, is what we're going to use. So the next thing we get to right here is the one that has the negative x. And we want to make sure that we keep the sign that's in front of it. And then we go across and it's this one right here. So it's the negative 5x. And then that's it. So the like terms there would be 7x, negative x, and negative 5x. So now let's look at the y's. We have a positive 4y and a positive 12y. We don't want to say or write the positives because it makes it messy. So let's look at number 2 and do the same thing. This one's a little more confusing because it has all x's, but remember the variable terms have to be exactly the same. So there is a difference between x and x squared. Remember, x squared is x times x, and x is just an x, so those are different. So let's go find all of our x's. We have an x, we have a positive 4x, and we have a 12x. So let's write those down. The reason I skipped negative x squared and negative 5x squared is because the x's did not look exactly the same. So now let's look at our x squareds. We have a negative x squared and a negative 5x squared. So negative x squared and negative 5x squared. Those are like terms. So now let's look at the next one. The first variable term I come to is this 5y, so that's where I'm going to start, and I'm going to go find all my y terms. 5y and a y, and there's no others, and I'm going to write those down, and then I keep on going. And the next thing I come to is this negative 3. That is a constant term. A constant term is one that does not have a variable like we said up here at the top. So the negative 3 and another one without a variable would be the 7. So negative 3 and a positive 7. And then I have this 5x, negative 5x just hanging out right here. It's all by itself. So all we did was identify the terms and the like terms for each expression. Terms are separated by addition and subtraction. So now what we are doing is we're looking at this right here, and we're looking at 6x. And what would I add to 6x to make it equal 10x? Well, just ask yourself, is 6x and 10x, are those like terms? And they are. So you would ask yourself, how many x's does it take to go from 6 of them to 10 of them? Well, 6 to 10 is what? Well, from 6 to 10 would be 4. So I would need to add 4 x's to get there. So we can rewrite this as 6x plus 4x is equal to 10x. How many x's would we need to add to 6x to get to 2x? Well, actually, we would need to go backwards to do that by 4. So it would actually be a negative 4x. So we could write that as 6x plus a negative 4x is equal to 2x. So you can see that we're just really worrying about our coefficients. 6 plus negative 4 is equal to 2. How would we go from 6x to a negative 10. Okay, I'm going to go and actually do some scratch work over here. 6 plus what equals negative 10? So what would I put in that question mark? 6 plus what gets me to negative 10? Well, I know if I subtracted 6, I would be at 0. And then go back another 10. So if I put negative 6 in here, that gets me to 0. And negative 10 would get me there. So that would be negative 16. So 6 plus negative 16, does that equal negative 10? I think that would work. So that would be a negative 16x. So 6x plus negative 16x would equal negative 10x. So we just treat like terms just like regular numbers, and the variable just comes along for the ride. That's it. It's just along for the ride. So how would I get to 0? 6x plus what is 0? Well, if this was 6, what would I add to 6 to get to 0? I would add negative 6x. Remember when we were doing adding integers and subtracting integers, we just said we would add that opposite to get to 0? So I would do the same thing here. So 6x plus a negative 6x equals 0. Notice I didn't write the x. It's because I don't need to. We're just going to say they went away, and I'm not going to worry about the x's anymore. Let's look at number 5. Is there anything that I could add to 6x to equal 10? Well, ask yourself, are these like terms? These are not like terms, are they? What would I have to do? Well, I'd have to get rid of the 6x, and I'd have to add 10. So this would have a whole lot more to it. This is something we'll do in class. All right, now let's look at this one. Okay, these are some ones we'll go over in class. Let's look at combining like terms. So now that we understand we can combine like terms, so long as they have the same variables and they look exactly the same, we just have to worry about the coefficients. So I like to go pretty slowly. I do 2 at a time, and we just work through it bit by bit. I rewrite the entire expression that I did not use. So here we go. I'm going to take my 3y and my 8y, and I did not use the negative 7y and the y, so I'm going to rewrite it. So what is 3y plus 8y? Well, what's 3 plus 8? 8, 9, 10, 11. It's 11y. So now I'm going to put my 11y, my 7y, but I'm not going to use this y right here, so I'm just going to rewrite it. And 11 minus 7 is 4y, and I ran out of room. It's okay if I run out of room. It's just if I run out of room, though, I need to tell you where I went to. I'm going to come right up there and make my equal sign. Okay, here's where we need to be careful. There is a 1 in front of this y because there are 1 of them. So what is 4 minus 1? 4 minus 1 is 3. So our answer is 3y, and we are done. There's nothing more we can do to that problem. It is finished. So let's look at number 2. If you look at number 2, you can see we have y's and we have constants. So there are 2 things going on here. So what we are going to do on this one is we're actually going to rearrange everything, and we're going to put all of our y's first, and then we're going to put all of our constants second. And remember to take whatever sign is in front of your term and take it with you. So here we go. We're going to take our negative 4y first, and when I've used it, I'm going to cross it off. And our negative 2y, and our negative 15, and our 2. Now, because the y's are working by themselves, and our constants are working by themselves, and they're never going to come together, I can actually do this work at the same time. Okay, here we go. Negative 4 minus 2. We're just worrying about the coefficients. The constants are coming along for the ride. So negative 4 minus 2 is a negative 6y. And then it's kind of like a pause. They're sitting in 2 different rooms. Negative 15 plus 2, that's a negative 13. Those are not like terms. We're done. So when you're doing problems like this, you want to put your like terms together. You want to put them in the same place. And then you kind of get to separate them out into 2 different problems that you're writing on the same line. Kind of cool. Takes a little less time. Okay, let's look at number 3. We have like terms again. We have a 2x, a 4x, a negative 7, and a 3x. That negative 7, I need to move it over. If you're really good, you don't have to rearrange everything. But for now, we're going to keep on doing it. So we have a 2x, a 4x, a 3x, and a negative 7. That negative 7 is never going to combine with anything. It's a loner. Okay, so 2 plus 4, because they're x's, they're just going to come along for the ride. So 2 plus 4 is 6. And then the 3x and the negative 7 come along. We have to write them down because this and this are equivalent. So we have to keep them equivalent. So we have to write everything down. So now we're going to do 6x plus 3x, which is 9x. Nothing happened to the 7, so negative 7. These are not like terms. We're done. So sometimes people get really confused with, am I done? Am I not done? Check your like terms. If there are no more like terms, you stop. That's it. You're done. Okay, let's look at this one. This one's confusing. All I see are x's. Makes you first think they're all like terms, but they're not, because this is an x squared and this is a 3x. They're not like terms. So let's put everything together. Let's put our x squareds first and then our x's. We always put the one with the exponent first and then the regular one. And this time I'm going to use 2 different colors to help us out. So I have an x squared, and I'm not scribbling it out. I'm just doing a quick line. A negative 4x squared and a positive 2x squared. Then I have a positive 3x and a negative x. If they're in the different colors, it's okay to work at the same time. If you're confused, just move left to right. Take more steps. Equals. This is a 1. So 1 minus 4 is a negative 3x squared. Nothing happened to the 2x squared, so it has to stay there. But this 3x minus x, I can do right now. What's 3 minus 1? It's just 2, but don't forget the x. And don't forget the positive in front of it. Negative 3 plus 2 is a negative 1. So 1x squared, or just negative x squared, plus 2x. And we're done. That's it. That's all you have to do. The hardest part on these is knowing when to stop. That's where everybody usually gets confused, is they go, I just don't know when to stop. So ask yourself after every step, are there any more like terms? And the answer is no, you stop. So that is it for today. Today you learned about like terms, you learned about constant terms, you learned about combining like terms, and you learned about terms. So a lot that we need in order to start working with algebraic expressions and then leading towards algebraic equations. Make sure that you practice these. Go ahead if you want and give set B a try if you want. And I am looking forward to seeing you in class. Remember, be kind to each other because we can all use some extra kindness in our lives. And I look forward to seeing you in the next lesson. Bye for now.